Paper. Alright, we are on day 1 notes, and that's as far as we get. I really don't want to get too far before the Christmas break because I'm going to have to basically start over anyway. We're on the back of that paper. And tell me what the last note we had on Friday was, could you please?
Expected value.
Alright, I gave a formula. Is that right?
Yeah.
Okay.
UX equals P.
Alright, we're going to talk about that. I looked up what that, all it was, remember X bar used to be the average of a sample. So if you had a sample, we add up all the numbers and divide by the number of numbers. And we called that X bar. If we had the mean of the whole population, we did just call it mu. So it was pretty, I think I was close to saying that on Friday. Now we're entering another number that's even close, is also close, and that's mu sub x. So this is where we are today.
Isn't that what we did yesterday?
Yeah, we are. So I'm just reviewing that.
Oh.
So it turns out what mu sub x is, could you read that note, Elena? What did we say mu, it's the mean of what?
The mean of discrete random value.
The mean of a discrete random variable. Alright, so we'll go over again what a discrete random variable is. We did that really well on Friday, but it was Friday. So we'll go over that again, and then the mean of it. The mean, however, I think this is a mean word to use in this definition. I think this is mean because it's not a mean, it's not a true mean where you add things up and divide by a number of numbers. So it's as if they have put this in to trick us. So I gave you the formula on Friday. Can you find that for me, Julia, on your notes? The formula for mu sub x?
Yeah, probability 1 of x1 plus probability 2 of x2 plus probability 3 of x3 and dot.
So this does not look like a mean to me, but it is called the mean of a discrete random variable. So if I ask for it, this is what I mean. So, little joke. Alright, so let's look at one. It's not going to make a lot of sense until we see an example. So we're going to go to the roulette wheel. Would you take a note for me? On the roulette wheel, there are 18 red spots. Red slots, I guess you call them. There are 18 black, and there are 2 green. Has anyone seen a roulette wheel? This one is, the one in your book's colored if you want to see how they work. I couldn't copy it with color. So we have 18 red slots, 18 black slots, and 2 green slots. So here's how you play the game. You tell me if you want to play with your real hard-earned money. Here's what happens.
Wait, can we play a game of this?
I don't have a roulette wheel.
But
We have Russian roulette.
I don't have a gun either, so.
You don't.
Oh well. Maybe I'll work on that over the break, coming up with a roulette wheel. Alright.
Or just play Russian roulette with a Nerf gun.
yeah.
But it's gotta go.
No, they make Nerf revolvers. We used to do that when I was little. We used to play Russian roulette with Nerf revolvers.
We had a Nerf
Okay.
revolver.
Alright, I got my work cut out for me to find a Russian
But except the
roulette
thing is,
game
sometimes
and
it
a
doesn't work, and
roulette
sometimes
game.
it would actually shoot, and you wouldn't even know.
So you throw the ball in,
You know,
or the
if you
ball
had
is
to shoot
in
in the head,
the center or
stop
something,
there.
you twirl it,
You
and the
would
ball
probably
goes around, and it's going to stop in either a red, black, or green. In order to play, you have to put in $1, baby, $1. And when that ball stops, if it lands on a red, you get your dollar back and $1. So that's if it lands on a red. Guess what happens if it lands on a black?
You lose the dollar.
Right, so the $1 you paid to play goes away. And if it lands on a green,
Sorry.
I don't know
Okay,
what
I was trying to
happens.
figure out a way around
You
it.
get 100, 1,
I don't know. I think that's all they told us. I'll have to
Move it
look
just
that
in the
up.
correct space.
All right.
Look it up on your
There you
phone.
go. You can
Okay.
to the top.
All right. Let's just say that green, you roll again. I'll look it up though in a minute.
I highly
So-
doubt they're gonna be
so-
fine.
We were talking last week about a discrete random variable. So remember, a random variable is a chance event. So here we have the chance event, and it involves an outcome and a probability. So what are the possible outcomes? We'll call our random variable x. So what if you play, and we're only playing with red and black, what could happen after one roll? What's a possible outcome for you as far as your money goes?
Yep.
If it's on a red, you get a +1, right? You already had $1, so your money's going to go up for 1. So that's a possible outcome. If you get a black, what happens to your money?
-1.
All right, so these are the only two outcomes that I'm aware of, because I don't know what happens when you hit a green. Now, to be a discrete random variable, it has to be discrete. Is there anything in between on this? Could you get $1.50, $1.75,
No.
50 cents? All right, it's discrete.
Discrete.
It's random, and the only thing else we need is the probabilities. So, those numbers will help us come up with the probabilities. So what's the probability of getting a +1, which is associated with the red? So how many red slots are there? 18. How many slots are there total?
18 plus 18
Plus 2. What's that, 38? All right.
And then if you get 47%.
All right, so, okay, 40, that's what the equivalent, 47? All right, so is a lower or higher probability of losing the money, or the same?
Same.
Well, let's see, because they got 20 out of 38, so I must not understand this game.
Maybe the green slots are considered black slots also.
All right, I'll have to look it up, hold
Green
on.
slots are considered black slots also.
Same.
I'll have to look it up, hold on.
Oh, do they ask for the probability of it not being a +1?
Not
That would
exactly.
also
You
have the
couldn't
green.
hold my-
Yeah, maybe that, here it is, let me read it. There are 38 slots numbered 1 through 36 plus 0 and 0, 0. Half the slots from 1 to 36 are red. The other half are black. Both the 0 and 0, 0 slots are green. Suppose the player places a simple $1 bet on red. If the ball lands in the red slot, the player gets the original dollar back plus an additional $1. If the ball lands in a different colored slot, so not only is
Different.
black a loser, but green is also a loser. All right, so that's where they get 20 possible out of 38. So Allie, what's that in percentage?
0.53.
So do you have a higher percent chance of losing? Slightly, slightly. So you got to weigh those odds. All right, so what I'm interested in this whole example for is finding mu sub x, the expected value. So what we're going to do, we're going to take each outcome, that's the x, and multiply it by its probability and add it to the next one. It won't take long, there's only 2. So take 18 out of 38 and multiply it by the outcome of +1, and take 20 out of 38 and multiply it by the outcome -1. What is the expected value when you play this game? Would someone calculate that and give me a decimal?
I got a negative.
That's right.
Negative 0.05.
All right, so over time, you are expected to lose money at this game. So when someone asks you to put your hard-earned money into this game, what should you say? No, thank you. All right. So here's how you find the probabilities, the expected value. It works like a probability. It's over time. So over many, many games, this is what you're expected to gain or lose. In this case, lose. Let's look at the APGAR babies. Could you give me the expected value for the APGAR babies? So that's on the front of your page. So according to this formula, the expected value, it's read the mean of the discrete random variable But more importantly, it's called the expected value. Because when you combine the probability with the outcome and add them all up, it is what you expect to get over time. So it's a good name. The mean is a mean name. The expected value is a nice name. Find the expected value of the APGAR babies. So if you have a baby in the future, this is its expected value. If you have 1,000 babies, this is their
1,000
expected
babies.
baby. The expected APGAR. All right, so you're going to take the APGAR of 0 and is there a 0? There is. And multiply it by 0.001. Not really necessary. 1 times 0.006. 2 zeros. 2 times 0.007, and so on. What is the answer? The expected value for APGAR. Julia, can you tippy tap 2? Tippy tap 2.
Is this the answer?
What do you say?
It's not.
It is, I think it is.
I'm just a little bit mixed up.
We haven't been timing.
Pardon?
We haven't been timing.
Oh yeah. Oh, we're not going to be saying anything much more. We're going to switch to do a couple problems, so we're almost done.
Alright.
If it's too long, I know how to split it up.
It should give a timer on it.
All right. Allie's got a number to confirm. What did you get? All right. Julia, did you have a question?
I haven't finished doing it yet.
It's each probability times each number outcome plus the probability outcome. So I started it for you for the APGAR babies. Multiply, add, multiply, add, multiply, add.
No, it's weird.
Do you see what we're doing?
I think so.
Where's your APGAR scores? Yeah. This will be this times that plus this times that plus.
Okay.
So just tap it out and see what you get. Does anyone confirm?
That's a
You're
pretty
quick.
good- That's a pretty good mean.
It is pretty good expect because health view they said was 7, 8, 9, and 10,
Yeah.
so that's good expectation. Except that, again, I had a baby with a 10 and it wasn't very long, man. He was in open heart surgery, so. So I don't have a whole lot of regard for APGAR scores, but our own experiences. You got an answer? Allie, how'd you do it? Like
I got
10?
one.
What'd you get?
8.128.
All right, let's switch.
I got 8.128 as well.
Okay, so is that a pretty healthy baby?
Healthy
They
baby.
said 7, 8, 9, and 10 are good.
Lena
So
was
we
so
have good expectations. All
Lena
right.
has today.
All right, let's do 2 problems that expect
Tonight?
us to find expected values. Would that be mean?
Daniel didn't know that was a thing. Okay,
All right,
told him
let's see
yesterday.
which ones I had
So
chosen.
that's what
There
we
was
think
some on a
about.
list,
She said, what do
and
you
which
think you
2 are they that I prefer? All right, you can turn off the, we're gonna work in class. I guess I should tell them what ones we're gonna do.
That's right.
Let's see if number 9 asks for compute the expected value and number 10. All right, we're going to do number 9 and number 10, and we're just going to do the expected value part of it.
What page is
It
it?
is on page 354. So those in video land, we're ending our year by doing
Ah!
No.
number 9 and 10 on page 354, but we're only doing part B and part B because that's computing expected
Wait, which-
value. So if you would go
Which
there
parts are
and
those?
do
D and B?
those,
B and B.
B and B.
B on each.
Part B on each.
B.
I'll erase everything but the regular formula for expected value.
So we signing off now?
We are.
Okay.
Have
Oh,
a
I want
great
everybody
end
to
of the
show their
year.
masks, but they're
This
not
is
wearing them.
is this the winter solstice or is it tomorrow?
Tomorrow is winter.
Tomorrow.
Okay. so
Brandon knows.
I think it actually, well, I
I
don't know
might
what
have it.
time of the day. It might come tonight. So I have to look
Okay,
that
I'll
up.
write that.
Lena, put
But
your
it
mask
might
on.
be the shortest night of the year and then we start adding daylight back. So, all
Scarlet
right,
Pimpernel.
over now.
Too high.
there a way to tell how long that was?